Okay, are we ready to move on to some telescope viewing? It may not be from Minnesota tonight, it may be from some other location in the Northern Hemisphere, but I'm excited to turn it over to Mark Jobe and his friends Dustin Haskins and Mark Boyd from the Minnesota Astronomical Society. So if we could have, let's see, Mark and Dustin and the other Mark come on. We can, we'll have you share your screens. Maybe Amber, if you want to unshare that, perfect. Mark Jobe, are you there?
Yes, I'm here.
Do you want to tell us where you are now and where our telescope view, or is that stealing your thunder? Maybe that's part of your presentation.
Yeah, maybe I'll keep some of that a secret.
Okay.
So Dusty and I and Mark Boyd we're all located in Buffalo. We're probably Buffalo, Minnesota. We're all probably only about not more than 4 or 5 miles apart. And it's kind of amazing. I have my observatory in the backyard, which is on this next slide right here. So that's my backyard observatory. It's a roll-off roof. It doesn't look like that anymore, I'll tell you that. It's awful white out there. And then I also have another observatory a little ways away in Texas, which I will share tonight for sure. So a little introduction for me. I've been an amateur astronomer and you know, maybe all my life, I guess, you know, because all it really takes is you know, just looking up in the sky and seeing the stars. But you know, ever since I was a youngster, I grew up in the center part of the North Dakota, and you know, it's always dark there, especially in the fall, winter, early spring. So I always had my friends. All the stars were always there. Northern Lights, all that stuff. You know, so I mean, I love it. So I've gone from the extreme of just having no equipment to having a bunch of equipment that I use to observe the sky. I really enjoy astrophotography. And so I've built myself facilities and acquired equipment so that I can do that. I'd like to turn it over to Dusty and Mark, maybe Dusty first, and he can introduce himself. He's kind of just getting started, so it's kind of fun to watch from my perspective. Go ahead, Dusty.
Thank you, Mark. Very much so, just getting started. My actual, I mean, as far as I can think, way back from when I was a little kid, I always loved looking up at the stars and everything like that. And I remember like riding on the lawn tractor with my dad and looking up and seeing the 3 stars, and I'm like, oh, that's Orion's belt, you know? I mean, it was awesome. But then as I got a little bit older, I moved down to southern Minnesota and down by the Worthington area. And we actually lived, I mean, the closest town was Worthington, which was like 12 miles away or whatever. So, I mean, going back in the pasture and just laying on the ground and looking up, I would do it all the time. So, I mean, that was kind of how it started for me. And then I bought a telescope because I had 1, 2, and in between 2 and 3 kids, I realized I had no hobbies left. I mean, none that I could do really, because I didn't have any time. So I'm like, I need something that I can do. So I went and bought myself a cheap telescope from Menards. And in fact, I have it sitting right here. That right there was the first one that I got. And it was one morning before work, I got up and I decided, I'm like, you know, I gotta try to find something. And I looked up and I found Saturn and I saw the rings, and right then and there, my very next words were, this is going to get expensive. And I bought my first mount in March, was when I first started doing astrophotography. And I think I don't even know how many scopes and everything else I have from that point. So yeah, that's kind of my background with it.
Okay, Mark Boyd.
Okay, well, hello, everybody. My name is Mark Boyd. I live just a few miles from Mark Jobe and Dusty. And in fact, Mark Jobe's observatory went up at the same time that my observatory went up. We didn't even realize we were building them at the same time. I'm retired from General Mills and have had more time to spend with astrophotography and the hobby of astronomy, which I've had since the age of about 9. And I think everyone can relate to the story Dusty just told about your very first telescope and looking into the sky and seeing for the first time the rings of Saturn. I think that captures parts of a lot of people getting started in astronomy, that moment to see those ethereal rings surrounding the planet. And I think observational astronomy and astrophotography, they all come along over the years, and it's just a wonderful hobby. We hope to be able to show you some objects this evening and talk about them too, you know, talk about what these objects mean and why they're important in the sky. So turn it back to you, Mark.
Yeah, cool. Thanks, guys. You know, all this talk about dark skies and all these places that are working on certifications and all the places that that Bob has been in national parks and things like that. And I went, wow, I have a lot of places to go, a lot of places to drag equipment. It was nice to see that he'd been to Acadia National Park and did a survey there. I did a star party there probably it's almost 4 years ago. It was awesome. So there was like 10,000 people there. I swear they bust them to the top of Cadillac Mountain. It was a blast. I had 2 telescopes set up and I was busy. So here we go. So here is the star. I'm using the star chart that is a reference off of the Bell Museum's statewide star party site. So I thought I'd use that because that was I think that's one that everybody has access to. So our first object tonight is in the constellation Hercules. It is M13. I also put another picture together just to show, you know, this time of night it's not the greatest. So this is a snap of Stellarium, a planetary program, and it's you can see it's not very high in the west northwest. So there it is. I took this picture from my observatory here in Buffalo. I used a wide field just to kind of give you a perspective of, you know, where it sits and how many stars are really around it. I'm going to turn it over to Mark Boyd, and he's going to talk a little bit more about the object itself. And when he gets to a point, I'm going to switch to a closer up view, a view through a 10-inch telescope.
Yeah, Mark, let me start. I think leave it on this image for a little bit here, because I think this one is a nice wide field look at this beautiful cluster. You know, it's one of the most favorite objects in the sky, I think, for beginning astronomers to start with. And, you know, this kind of has the look of what this is through maybe a 6 to 8 inch diameter telescope. Smaller telescopes, of course, you know, in a 3 or 4 inch size would probably show it really more just as a fuzzy little round spot. But you begin to see, you know, in this kind of picture with this kind of magnification, how the outer envelope of the object starts to have the individual stars resolved nicely. And it only gets better as you go up with larger and larger telescopes, but it still presents a beautiful view in a nice dark part of the sky. You know, this is a globular star cluster, M13, and it's an amazing object, really. It teaches us a lot about, you know, the history of our galaxy. You know, these star clusters have hundreds of thousands of stars in them, and they are very old. This one in particular is about 20,000 light years away. And they're some of the oldest objects in the galaxy. And in fact, we have about 100 to 150 of these types of globular star clusters, just like this, of various sizes and distances, that surround the core of our galaxy. And as astronomers have studied this over time, they've learned that basically these star clusters formed in the very early stages of our galaxy when it indeed was still round and not flattened into a spiral as we know it today. So it's probably 10 to 12 billion years old. The stellar populations of these stars are recognized as being very old. There's some very few new ones, but in general, these are what's known as population 2 stars. An interesting fact, if you lived on a planet in the center of this object and you looked out onto the night sky, you would see an amazing, spectacular sight. Because near the center of this galaxy, this globular star cluster, the star spacing is only on the order of something like the size of our solar system. So you would be living in a place where the sky would be filled with intensely bright stars, brighter than any stars we have in our sky. And in fact, there's so many of them, and they would be so bright that it wouldn't even seem like nighttime ever came. And so it's a very unusual object. It's again, the nature of the object has taught us a lot about the evolution of the galaxy itself. And studies have really learned a lot about how these things have changed over time. They're literally like little miniature galaxies, so to speak, but they don't really behave in the same manner. There's a lot of stars, like I said, hundreds of thousands of stars, and they actually mass segregate over time. They evolve in the nature of their structure. So when you're looking upon this object with your telescope in the late fall evening, there's a lot to be discerned in this thing. It's a beautiful object. It has many sort of star trail-like asterisms within it, and they even become more and more evident with going to a larger and larger telescope. But it's a fascinating object, and it's quite frankly unlikely that any Earth-type objects exist in this cluster. These stars are predominantly very old stars, but they're predominantly helium and hydrogen. They've never really developed the metallic content that is known so well, for instance, in the nature of the area where we live. You know, our Earth is a rocky planet, iron core. It needed a lot of iron to develop as it did. But these stars never really developed in an area where the sky or the space would have been enriched with a high level of metallic components. So it's kind of a whole different environment. So an earthy rock-like planet would never exist there. So there's a few elements of this thing that make it very interesting. I think the high-powered view begins to show you the nature of the lanes of stars that develop. And no matter what you do, even with a big telescope, amateur standards, the core of this thing is very dense and you really can't see through it. Even though I think the very largest telescopes can begin to resolve close to the center, it's a fabulous object to look at. Anything else you got to add, or?
No, I think that's great, Mark. Good. So let's move on to our next object. Our next object is going to take us to the constellation Lyra. It's known as M57, one of Messier's objects that he identified as not being a comet. And, so kind of give you an idea of how you would find it with bright stars, against the night sky. Your the brightest star, Vega, and is going to be one of your main guide stars. And then knowing where Vega is, you can identify the other stars. So it's located there between those two stars on the end of Lyra there. And there it is. This is. I'm going to turn it over to Mark again, unless Dusty has something to fill in on that. This is taken through a 10-inch telescope. It is one exposure at about I think it's 600 seconds, so that's 10 minutes. And there it is, guys. You can talk about it.
Yeah, here we have another one of the most spectacular objects in the nighttime sky, and usually one of the first, I think, that I train my telescopes on when I want to show people a really fun object. You know, this is an example. It's called the Ring Nebula, but it is one of the best examples of a whole class of objects called planetary nebulas. And these are really, really interesting objects to study. This thing was actually found back in 1779 and with a 3-inch telescope. So it actually can be found with a small telescope. Now it won't have this donut look to it. It'll tend to look more like just a small disc. As you get to the bigger and bigger, like 6 or 8 or 10-inch telescopes, that's when you begin to resolve the nature of the donut shape. And of course, in larger telescopes, it actually begins to take a little bit of color on the fringes also. It's a fascinating object that represents part of the last parts of a star's evolution in life, so to speak. It's a beautiful object also because it sits in a super rich part of the Milky Way. So really just, you can see how the field is just dominated by so many bright stars. This thing literally lasts in space for a period of several tens of thousands of years. And it can be said it's almost like a smoke ring surrounding a star at its center that literally that star shed part of its mass into space over time. This usually happens during the transition from the point when a star is a very large red giant stage to the point where it converts to a white dwarf star. There's a lot going on, and I'm not trying to claim to be an expert in how that transition occurs. But when it moves, the stars become unstable at certain points and they shed a lot of their mass. In fact, the mass of this thing, it's not a huge amount of mass. It actually is equivalent to about several Earths of mass, okay? But it's spread out over a big area. And the reason we see it so well is because of that center star. That center star is a white dwarf star. Now, a white dwarf star is something that has burned through a lot of its thermonuclear processing, and in the end, it has converted itself into largely carbon and oxygen. And what in it is a super hot little star. And the reality is that the energetic particles at this super hot temperature, it's like 85,000 to 100,000 degrees Kelvin, that center star. And it literally is an energy source that behaves in essence like it's creating fluorescence, so to speak, of the outer gas ring. And it does this by just the photons and the electrons that are emitted from that little star as they zip through space and they hit the outer regions of this gas cloud, which has by the way, a lot of nitrogen and oxygen in it. And it makes it fluoresce. And it turns out it fluoresces in kind of a blue-green wavelength. And a lot of these planetaries we see in the sky with different telescopes are almost notably bluish and greenish. And it's because of the same phenomenon of fluorescence. And it turns out that, and it's an interesting term, the fluorescence actually occurs at a wavelength which was actually called the forbidden light, because they couldn't figure out from spectroscopy why emissions would be occurring in that blue-green area of the spectrum. And it wasn't until they really coupled together the idea that bright ring, while we see it bright, is actually extremely rarefied. It is very low density. And in that case, those electrons and photons streaming from that white dwarf can actually strip and ionize the oxygen, not just once, but twice. It's actually a doubly ionized oxygen atoms that fluoresce in a place where they never would have guessed it, in the blue-green zone of the spectrum. So it's a very curious, cool thing. And here's an amazing feature of this object. When you look at it, especially with a larger light, to see the central star, that white dwarf is such an unusual class of objects. In recent reading, I learned that it's been possible for researchers to actually measure the oscillation or the seismic activity of those little stars. It turns out they're not very stable, and they shake and they buzz and they oscillate. And the ability to, and they do that according to the light emissions curve of that star. So when you're looking at this object, it's fascinating to understand that astronomers have perfected the means to actually watch the light curve of those white dwarf stars and understand the nature of their oscillations that they're going through and their instabilities. It's a fascinating area of astronomy science, I think. Anyway, it's a favorite object. It's one of the best planetaries, and you're going to see it with a small scope if you look for it. It's got nice guide stars to help you get there. And it is not a supernova remnant. It's quite different. It represents an evolving stage of star near the end of its lifetime. And it's about 2,000 light years away.
Hey, Mark Boyd, this is Holly jumping in. We had a question from Michael in our audience who was wondering what magnification is that image that we're seeing of the Ring Nebula?
I would guess this would represent about 50 to 80 power, somewhere in that range. Mark Jobe?
Yeah, I guess I don't think about it that way. I think about it as what's the image scale. So if I have to guess, I know the image scale of this telescope camera is about about a half an arc second per pixel. So that would make this, I think if I remember correctly about this, because I have so many, I have a hard time keeping track of combinations. I believe a half a degree from left to right, so if I put the full moon in this image, the full moon doesn't quite fit. So that is probably, so I guess I can't guess from there, but
I would say visually, Mark, just looking at it, this, if you have let's say a 4 or 6 inch telescope, you'd want to get an eyepiece of a pretty good magnification before you would begin to see the nature of the donut. And I would say you're probably going to want to be 50 to 80 power to begin to see that donut develop. If you have a smaller telescope that's not there, maybe it's 20 to 30 power, you'll probably see it as more or less a small oval. But as you get larger like this, it's probably, I'm guessing 50 to 80 power. If you were to take it up to, let's say, a telescope capable of 150 power, let's say, it would look like significantly larger in the field. If this square area were more or less the field of the eyepiece, you would see it growing pretty substantially. So target maybe 80 power in your telescope.
Yeah. Okay, let's move on.
Yep.
So our next object is in the constellation VULPECULA, and VULPECULA is not on the Bell Museum's. The constellation is not on this star chart, but I do see M27 right there to the left of Albireo. And I say left, it's really to the south of Albireo in this chart. So I got a couple extra pictures here to show where VULPECULA is, and as I zoom in, you can see that it's between Cygnus and Sagitta. And it really is on the border there. It's kind of out there in nowhere's land. There's when you look through a telescope, you're going to see a bunch of stars there because the Milky Way is right there. So you're going to have to really use the bright stars to give you a guide. The bright star there that you see right in the middle is the head of the swan of Cygnus. That would be the best one to get you over there. So here we are, M27, the Dumbbell Nebula. A little description of that from Mark. Maybe Dusty, have you ever looked at this through your telescope, being a newbie?
I actually have. And the first time I found it was with my 10-inch Dob. And I remember looking up and thinking, gosh, what the heck is that? It was just kind of like a little blue dot. It didn't look like like any normal star when I was looking through it. But yeah, I don't know. The one thing I will say about it is, as far as brightness is concerned, the dumbbell is, it's, as far as brightness for planetary nebulas, it's a pretty bright one to look through, to actually see through a scope.
Yeah, this one, I often see it in my finder scope. So it usually shows up, you know, like a 7 power. So grab the binoculars. In fact, it's a great way to look for this object. From the star map to the binoculars, you will see it for sure in reasonably dark skies. And then it would also then extend to the finder scope for whatever telescope you happen to be using. If you have reasonably dark skies, you'll see it directly. It's a kind of a nice little hazy patch. The thing about this one, of course, another classic example of a planetary nebula and another white dwarf at its core, is that this one is close. This is only about 1,000 light years away, and it's really an extended and large object, especially for smaller telescopes to be able to see nicely. And you can kind of see from the picture how it sort of has a flattened look to it. You know, it has like a large spot on either side of the center star, like a dumbbell, a weight dumbbell would look, or as Mark, you were telling me earlier, kind of an apple that's had a couple bites out of it, for instance, kind of an hourglass shape. And so this one's closer. And I think that's partly why we get the brightness and why we get the large image scale. This one is quite a bit larger than the previous, you know, M57. M57 is only about, you know, not part of an arc minute, you know, 71 arc seconds. This thing is about 5 by 8 arc minutes, which makes it quite a large object in the small telescopes. And it's one of the larger planetaries in the whole sky for us. And the beauty of this one, I think also, and I mentioned on one of the earlier ones, is that you are looking straight in to the richest star field in the sky. You know, Cygnus, the Swan, the Milky Way, you can hardly look anywhere without seeing hundreds of stars, whether it be your binoculars or your small telescope. And so it really creates this beautiful illusion of kind of this object, this ethereal, ghostly looking object, kind of hanging there in space against that beautiful dark backdrop of the sky and all the really bright stars that surround it. So it's a very, very beautiful object to look at. And I think always new folks to astronomy are always delighted to see it. And there's lots of oohs and ahs at the eyepiece. Of course, this one has all the same characteristics of M57, you know, the nature of the color and long-term photographs, you know, the doubly ionized oxygen. You know, this one's an easy one. This one's a good one to go find it. You know, grab those binoculars and get out there and take a look at it. Even a small telescope, you will find it. So it's, again, the funny name, the white dwarf star, kind of the interesting history that goes behind our understanding of stellar evolution, and just a nice object all the way around.
All right, moving along. Kind of changing gears here. We're going to Perseus now, and we're going to look at a double cluster. So Perseus, down there between, kind of between, wedged in there, I guess, between Cassiopeia and Andromeda. You know, and a couple other little constellations that you really can't see very well, at least even from my sky out here. But there it is. It's. I always thought that the double cluster was part of Cassiopeia, but I was corrected in preparation for this. So here's the double cluster. Dusty, have you ever looked at this one? You can actually see this with your naked eye.
This one you can see with your naked eye, yes. This one I have seen, and I actually tried taking a picture of it with my finder scope on my Dob when I was just starting out. And of course it turned out absolutely terribly because I tried doing it with my cell phone, hand holding it. But yeah, when I first found it, I remember sitting there with my Dob looking up and seeing it, and you know, just because I was following all the stars through the Milky Way as I got there, and once I hit that piece, I'm like, holy cow, there's a ton of stars right there. You know, I mean, it's as far as being like a globular cluster, it's not as packed, but when you see that many in one spot, it's pretty cool. It really was. So
Yeah, this is like the Big Easy one in the sky.
is.
It is so big that honestly, you're really best off finding this thing very easily in a pair of binoculars and enjoying the grander view of the Milky Way in that whole area between Perseus and especially in the Cassiopeia. That's just so rich with other star clusters and just a myriad of stars. It's one of the richest places to look, you know, and it's this one, you know, is so large. It's I think these things are almost a 1 degree apart. So really, if you have any magnification on your scope at all, you're really going to be looking at just one of the two clusters at a time. And in order to get both clusters in the same field of view, it's got to be a smaller scope with a very low power eyepiece, kind of a richest field telescope, really, in order to see this thing in its completeness. But if you dial up the power a little bit, depending on the nature of the telescope you have, and the more you look at it, individually, you will discover a beautiful richness in each cluster itself. In fact, there's a number of little what we call asterisms, you know, where the stars form special little shapes and configurations that experienced observers look for. And one of the larger of the two clusters actually has a beautiful little asterism in my mind. It looks like a parachute with a little yellow star where the parachuter would be. It's very fun to look into these star clusters for those kind of asterisms. Each one of these star clusters has probably 300 to 400 stars in it. And what's amazing about this thing's over 7,000 light years away. It is a long ways away. And the fact that we see it so boldly and so brilliantly in our night sky is because the stars that make up this thing are blue, white, supergiant stars. They are immense. And it's if you again transported yourself to this star cluster and you turned around and you looked back, our sun would be like a 16th magnitude star. You wouldn't even see it unless you had a very powerful telescope. So it gives you an idea as we look from our house to that place, just how intensely bright those stars are. Basically, most of the stars in these clusters are what you might call spendthrift stars. I mean, they are super giant, hot stars, and they are burning through their nuclear fuel really fast to create that light. These stars are not going to last long. This thing is probably, you know, in that range of 5 to 10 million years old. It's young. It's really young, as a lot of these open star clusters are. They're formed from very brilliant, hot blue stars. And the characteristics of of those stars, because they're large and because of their temperature, they tend to really burn their nuclear fuels up really quick, and they burn themselves out quick. And in fact, actually, within some of these stars, there actually are stars that have evolved already to the red supergiant stage. And so with a telescope, if you look carefully, you will find some red cast stars in each one of these star clusters. So low power, go find it. It's easy. Start with binoculars, work your way up from there. Look for color with the larger telescopes. And that's what we've got with this object. Brilliant.
Okay, moving along. Another cluster in Perseus. So let's see, Perseus. There's Perseus. We've been there already. We already talked about it. This one's in a little different place. You know, it's close to Andromeda. There it is, M34. That's the only way I know it as. I can't see how Charles Messier could mistake that for a comet. I guess he that's a long time ago. So go ahead, Mark.
Yeah, this one, again, another classic example of an open or galactic star cluster. Those star clusters that formed out of gas clouds right in the spiral arms of our galaxies. This one in particular is an older version of this. Older for this meaning, you know, maybe 200 million years old. So this thing has already kind of evolved along, and it also, these stars, because they're so intense and bright, have blown away any of the remaining gas nebula residue that might have existed in the area. It's probably, according to, you know, photographs taken with bigger telescopes, there is as many as 400 stars in this cluster. So it's a very rich cluster. But with the amateur telescopes, you're not going to see that many. And it turns out that even within this cluster alone, there are already some approximately 20 white dwarf star candidates. So these stars, again, burn quickly through the evolutionary stages of stars and end up, you know, at the white dwarf stage already. But 1050, you know, this is a half a degree field. It's a big cluster. So, you know, something like 750 binoculars or 1050 binoculars would be stunning for this. This is just another beautiful example of this thing. You know, it's in particular, I always see these open star clusters as stellar nurseries. You know, while this one's a little bit older, you know, many that we do see still are surrounded by a lot of gas clouds. And it's always fun to think about how those stars probably more recently formed. Now, this one is an example that has formed and, you know, moved on, but many of the open star clusters do have associated gas clouds with them too. We're not showing you one of those tonight, but it's very common, especially as you look into the southern Milky Way.
Okay, next object is one of my favorites. It's one of my favorite things to do. I like to go. I follow a couple guys, or actually, I follow this website. They are supernova hunters. So I always like to look to see what's the new discovery of a supernova and see if I can go find it. Well, about 2 weeks ago, in this galaxy, and this is a very dim galaxy in Pisces, NGC 514. You know, and it was so it's located there. You can't see it without a pretty powerful telescope. Even in my telescope, there was this is a 10-minute single frame. You can barely see the galaxy there. You can see the galaxy core. I'll put my mouse on it. There's the core of the galaxy. The galaxy kind of goes all the way around here. But the cool part is the supernova. This star has exploded, and we're just seeing the light now. I know, Mark Boyd, I know you did some research to find out how far away this thing was. I do want to say that the stars that you see here are in our galaxy, but that supernova that you see, that is in that galaxy, and it's however million light years away.
Yeah, I actually didn't find a number, but I can tell you this. I don't think it's part of the local group. I think it's part beyond the local group, and it's probably hundreds of millions of light years away. It's a distant and old galaxy. And the fact that it has a supernova occurring in it is another interesting indicator. Typically, supernova like this don't occur in younger galaxies. The older the galaxy typically is more populated with those white dwarf stars that have evolved well along their evolutionary path. And in fact, here again is an example where a white dwarf class star, this is a type 1A supernova. And I don't think I'm really capable of getting into the dynamics of what exactly happens, but one scenario, there are a couple scenarios that can create a supernova like this. And one is where two white dwarf stars merge together and create such an unstable circumstance that they basically blow themselves apart. Another one is where you have a white dwarf star, a small white dwarf star, circling a large red giant star. And it accretes so much of that mass so quickly that it creates an unstable condition. This point, the supernova point there shown in the diagram, is literally the complete thermonuclear destruction of a star. And And that's why we get such a brilliant, flash of light over hundreds of millions of light years away. They are literally, the fireworks of the universe. And we see them in many, many other galaxies. And it's a pretty cool thing, Mark, that I think you're following these guys trying to capture this on film.
Yeah, so this, to kind of give you an idea, I know one of the earlier presenters tonight, I think the keynote speaker was talking about magnitudes of stars. So the magnitude of this supernova is down there around 13, 14 magnitude. So I can typically only see stars, I think, like 18 magnitude with my camera telescope combination. So it's dim. I think you'd have a hard time seeing it you'd have to have a pretty big telescope with pretty high power, and you'd have to know exactly where to look. So now our next object, we're going to change gears, and I need just a couple seconds. Let me get something started over here.
I think while you're doing that, Mark, let's ask Dusty about his first impressions of the Andromeda Galaxy.
Yeah, there you go. My first impressions of the Andromeda Galaxy, I was floored. I remember when I first kind of started looking, I remember looking for days and days trying to find a deep sky object after I found Saturn. And I think the first one I found was the Cigar Galaxy and Bode's Galaxy. I found those two, and that was just kind of a fluke. But then I'm like, Andromeda should be up. And I waited and waited. And when I finally found it, to be able to see an actual swirl with my telescope, everyone says it's a faint fuzzy, but when you're looking through, even at that time, I only had a 6-inch Dob, and I was able to see the swirls in it. And that right there was enough for me to just sit back and think, gosh, all of my problems that could be going on, or anything that could be going on, I'm just this little tiny point in this gigantic galaxy that's here. And then there's Andromeda that's over there. That's even, it's bigger than us. It just made anything that could have been happening, it just made it all seem so small at that point. But yeah.
Cool. So Mark, tell us where you got this image.
All right, so what I've done is I have switched computers, and the computer I'm using now is connected to my remote observatory in Texas. I can control this telescope from my comfort of my desk in my office. And what you're seeing here is actual live capture of the Andromeda Galaxy. I made some adjustments. So right now we are taking 30-second exposures, and we're stacking them, and we're at the process of doing this live stacking. It is actually removing noise as we stack it. I'm trying to make some adjustments to just enhance it just a little bit so it's a little better. And then I'll make it full screen, and you'll be able to kind of get an idea. But what's nice about this is in this picture, there's actually 3 galaxies. Obviously, the big one is M31, which is an Andromeda Galaxy. Also, long time ago was identified as the Andromeda Nebula. And then there's what?
M32.
M110 and M32. Are those the other two?
Right.
But what I like about this is, it's so bright. It's challenging because you can get carried away and get way too much exposure. It is it's the closest galaxy to us. That's the cool part. And one day the Milky Way and the Andromeda Galaxy are going to become one galaxy. I'm certain I won't see it.
This particular object, besides this image looks fantastic, Mark. I think along the lines of Dusty's first impressions of this, when you see, I always think about my first glimpses of this object as the kind of the really the beginnings of fall. It's like it always reminds me of the cool, clear nights of fall when we see Pegasus and the Andromeda constellation rising in the east, and you capture your first glimpse of this naked eye object. You can bring your binoculars, but you don't have to. This thing, if you have any kind of reasonable dark skies, shows very nicely as a nice little oval patch. And once you know where to look. And so, it's kind of a beautiful thing that happens every fall. It kind of reminds me of the best of the observing season begins when this thing starts to rise. This thing, and I can guarantee you, has been seen through the ancient eyes of many people going back thousands of years, because this thing is so bright. I found some notes around this that, the Persian astronomers actually did record this thing. They called it the little cloud because they didn't know what it was, obviously. But it's so bright, I'm sure that ancient people saw this thing going way, way back. So it's been on star charts long before telescopes ever arrived because it's so large. And it is the brightest and nearest of all the galaxies for us, if we exclude our own satellite galaxies. This thing is like 2.5 million light years away. So it's pretty close. When you think about the diameter of our galaxy being, the stellar disk being maybe a couple 100,000 light years across, and then you imagine, this thing being 2.5 million light years. So, when you get a factor of 25 or so, I mean, it's really close. And that's what has made this object so important also, I think, in the study of astronomy. In fact, it wasn't long ago, and I say this a little goofy, I mean, in the 1920s, astronomers did not know if this was a separate galaxy or not. And there was a great debate, it was called. Harlow Shapley and Eber Curtis had the great debate, and that was in 1920. And they were both excellent, superb scientists in the field of astronomy, and they were looking at this conundrum: how do we figure out what this object is? And we didn't quite have the tools perfected yet to figure it out. They knew it had the spectra of stars, but they couldn't figure out if it was near or really far away. And it wasn't until 1925 when Edwin Hubble trained the 100-inch telescope out in California on this thing, and he was actually able to find in the spiral arms of this galaxy a class of variable stars called the Cepheids. And he recognized those stars as being identical to stars he had seen in our own galaxy. And by translating the brightness of those stars, which as a class generally have about the same brightness, when he looked at the brightness and compared them of stars he knew in our own galaxy versus these in the distant Andromeda galaxy, he was able to determine that this thing was such and such a distance away. And more importantly, he was able to determine this is not part of our galaxy. Before 1925, people thought everything was just part of a giant, supergiant galactic object to which we belong. And I think it was in 1925 when they resolved this, it suddenly opened up the nature of the universe to knowing that there are island universes like our galaxy, island galaxies all over the place. And it really made the universe big. So you can rack up to Edwin Hubble, 1925. And it's impressive whether it's through binoculars or a big telescope. And even in your picture here, Mark, I think you could even point out knots of nebulosity and clouds of features. In fact, if you look at the very top of this picture, right under where it says star trib weather, weather, right? Right below, there's actually a knot of a giant cluster of material, star clusters or what have you. People have also recognized in this galaxy and studied globular star clusters just like M13, the one, the object we started with tonight, and have recognized that this galaxy, somewhat larger than ours, has probably 400 or 500 of those globular star clusters in it. So it's a fascinating object. Because it's so close, we've been able to learn so much about the distances and yardsticks of the universe.
So there it is. Andromeda Galaxy, live from Texas.
Right? Cool.
Hey, that's pretty cool, especially, since we have cloudy skies in the Twin Cities tonight. I wanted to let you know, friends, that we are running a little bit out of time. It is almost 10 o'clock. And I wanted to make sure that we had a couple of questions from the audience that I wanted to make sure that we could get to. So one of those was wondering if you had a recommendation for any website or book that is sort of an astronomy for dummies that has basics and definitions for non-science people.
Well, my always go-to book is Turn Left at Orion. That's the first one.
Yeah,
Exactly what I was going to say.
Yeah, I think all of us in the beginning need to start out with orientation, so to speak, like Mark's suggesting. To learn the night sky, it's best really with a pair of binoculars in a lawn chair, not a telescope. And I think that there's just a lot of material out there for beginning astronomers, especially there are several books like the 50 Best Objects in Small Telescopes. I don't remember the author. There are a number of them that are actually geared to folks just getting started.
Mike Lynch.
Yes.
Of WCCO has got a great book also. Why can't I remember the title of it? I think I own 2 copies.
If you do a search for beginning astronomy and observation, several books show up that are nice guides to the night sky for beginners.
That's fantastic. All right. And because, we've been streaming for 3 hours straight tonight, and, some of us are getting a little punchy. There was a question wondering if any of you have seen a unidentified flying object, and if you care to comment.
Never.
I'll comment. I'll say no.
It is interesting because, people that observe a great deal out in the night sky, you're out under the sky, you're in different locations, you're doing all this stuff. And those are the people that never usually have a UFO story.
Right. Exactly. The closest thing I have to a UFO story is, I think it was, let's see, August or September, whenever NEOWISE was big. I already forget. August, I guess. I was in North Dakota visiting my in-laws, and I took a night off because I actually planned the trip so that it was going to be during new moon. So I was out just shooting NEOWISE and shooting the Milky Way and things like that. Well, I was bending down to make some adjustments on my calendar or on my camera, and out of the corner of my eye, I caught this streaking light, and I just glanced up just at the right time, and it was a meteor. I mean, it literally scared me that I actually went, whoa. I mean, it felt like it was going to take the top of my head off. I mean, it probably was the fact that I was in a pitch dark place. That was one of those nights where, as I told a friend of mine, I go, we used to complain when we went to dark places that the Milky Way is so bright, it's annoyingly bright. Well, I found that because where Jupiter was positioned almost all summer was, right near the core of the Milky Way, that it was annoyingly bright. I couldn't even look that direction because I felt like it would ruin my night vision. But it was one of those where it was so bright that it scared me. And it was just a meteor. So that's the closest I have to being an unidentified flying object.
Thank you for sharing. Are there any last looks or things you wanted to point out quickly before we sign off for tonight?
Yes, I have one thing just for Sarah. I have to switch computers.
Our planetary programs coordinator.
I have to switch computers. Let's see, where is it? Here is this. Hit share. Just bear with me for 2 seconds. Here we go. Am I on this one? Here we go.
You see the star chart.
Yeah, it's not the star chart, I'll tell you that. One last picture.
Okay.
From North Dakota, Aurora Borealis, Northern Lights. You know, this is the farm where my wife grew up. But what's really cool is off there to the right, you can see Pleiades. And I bet if you look closer, I can't see it. I can't see Andromeda in this picture, but it should be there. Maybe it's above. But I wanted, you know, and it, you know, I think the tail end of the Milky Way is there. That's the opposite end. But there you go. That's where I'll leave it for tonight.
That is fantastic. I'll tell you, you colored Sarah Comparud impressed. It's on her her bucket list. So Mark and Dusty, thank you, and you're for being with us tonight and representing the Minnesota Astronomical Society. We were so delighted to have you, and so grateful that Mark Jobe, you had a telescope in Texas with clear skies that could take that had some good pictures to share with us tonight. So
yes, you're welcome. Thank you very much for having us.
Good.
I had a blast, and
been very fun.
It looks like tomorrow night's gonna be clear, so you guys are gonna be on deck tomorrow night.
Woohoo! We are excited. Thank you. Well, Mark, I'm going to ask you to stop sharing your screen as we wrap up tonight. Take one last look, people, at that beautiful Aurora Borealis. All right. Well, I want to thank everyone in our audience and all of our fantastic guests this evening. We had a jam-packed evening, and thank you to our audience for all your great interest and questions. Did you know that the Bell's free virtual programs are made possible through the generous support of donors like you? Each time you make a gift of any size, it expands the museum's ability to ignite curiosity and wonder on site and here online. If you're interested in making a gift, please visit our website, click Join and Give at the top of the page. You'll see the link on the page. And remember, tomorrow, this was only day 2, my friends. We have 6 days of nonstop fun, so that tomorrow evening, we have another exciting lineup beginning at 7 p.m. Central, featuring astrophotographer Mike Shaw, the Universe at Home from students with the Minnesota Institute of Astrophysics, and live telescope observing from the Bell Museum observation deck. As Mark Jobe told us, and as I looked at the weather forecast on my phone app, the weather forecast looks really promising tomorrow. So we're hoping to have some great views from the Bell Museum's roof deck. I want to say thank you. Good night, and we look forward to seeing you again tomorrow.
Good night, everyone.